Alright, so we are going to go through exercise 3H, which is all about number patterns. What are our learning intentions? To understand what a number pattern or number sequence is, to be able to describe a pattern where there is a common difference added or subtracted, to be able to describe a pattern where there is a common ratio multiplied or divided, to be able to find terms in a number pattern which with a common difference or ratio, so both of them. Perfect. Let's just go through a bit of theory here. So number patterns are also known as sequences, and each number in a sequence is called a term. Each number pattern has a particular starting number, and the terms are generated by following a particular rule, and that rule is either going to be a common difference or a common ratio, and we're going to be seeing that now. So let's first talk about common differences. So what is a common difference? So terms will increase or decrease by a constant amount. So let's now go through two examples. So here I have a number sequence or a number pattern. And as you can see, it goes 7, 10, 13, 16, 19. Now hopefully you can see a pattern there. I'm plussing 3 each time. Each time I'm plussing 3 to get my next term. So what we would say is that the common difference is 3. That's what we would say there. Nothing too tricky. Let's now look at this one. Here we have 49, 43, 37, 31, and 25. Well, how am I getting the next term each time? Well, it's quite clear that I'm subtracting 6 each time. Each time I'm subtracting 6. So we would say that the common difference is 6. And that's what it means to have a common difference, that you're increasing or decreasing by a constant amount. Let's now move on to our next type of sequence, which is common ratio. So what is a common ratio? So terms will divide or multiply by a constant amount. Let's again go through two examples. So here we have 2, 6, 18, 54. Well, to get to 2 to 6, I multiply by 3. 6 to 18, I multiply by 3. 18 to 54, I multiply by 3. So we would say that the common ratio is 3. Perfect. Let's now look here. I have 256 to 64 to 16 to 4. Now it's actually a bit trickier to use these bigger numbers to figure out what's going on, but if we came here from 16 to 4, I know I'm dividing by 4. And 64 to 16, I know I'm dividing by 4. And you know what? That looks like it's dividing by 4 as well. So when you've got big numbers like this, it always helps to start with the small ones. So it's quite clear that I'm getting each new term by dividing by 4. So what I would say is that my common ratio is 1/4. Now, the reason why we say that is because to divide by 4 is the same thing as to times by a quarter. So the common ratio we would say is 1/4 of each new value, a quarter of the old value to get the new one. All right, so let's now go through some examples that you'll see in the textbook. So these are the type of examples you're going to see in the textbook. So it says, find the next 3 terms for each of these patterns. All right, so we need to find the next 3 terms. So let's start with this one. And we've got 2, then we've got 6, then we've got 10, then we've got 14. Well, the difference between 2 and 6 is 4. And then the difference between 6 and 10 is 4. And the difference between 10 and 14 is 4. So it's quite clear that I'm plussing 4 each time. So what we could say is I have a common difference of 4. Common difference of 4. And that means my next 3 terms will be 14 plus 4, which is 18. Then it will be 18 plus 4, which is going to be 22. Then it's going to be 22 plus 4, which is going to be 26. And there you go. Let's now look at this one. Here we have 2 to 10, and I have 10 to 50. Well, if I have 2 to 10, I must be multiplying by 5, and 10 to 50 is also multiplying by 5. So to get my next term, I'm going to have to multiply by 5 again. So I'm going to go 50 multiplied by 5, and that's going to be 250. So this will be 250. And then I'm going to take 250 and I'm going to multiply that by 5. So 250 multiplied by 5. That's going to be 1250, 1250, and then I'm going to take 1250 and multiply that by 5, and when I do that I get 6250, 6250. So there you go. So for this one I have a common ratio of 5. Okay, let's keep on going. So for this one now, I have 99, 92, 85, and 78. It looks like I am subtracting 7 each time, doesn't it? 92 minus 7 is 85, 85 minus 7 is 78. That looks good. So if I want to go 78 minus 7, that will take me to 71. If I go 71 minus 7, that's going to take me to 64. And if I go 64 minus 7, that's going to take me to 57. Perfect. And that is our answer to that one. And if you wanted to, you could just write down common difference of 7. All right, let's now do our last one. And you might like to pause the video and see if you can answer this one for yourself. That's always a really handy trick when doing these things. You don't want to just be mindlessly watching these videos. If you are watching them, you want to make sure that you're giving it a go as well. So how about you pause the video and you give it a go. All right. All right, hopefully you gave that a go. Let's now go through it together. So it's 256, 128, 64, 32. When I have big numbers like this, I actually like to start with the smaller ones. So the difference between 64 and 32, I know that's dividing by 2. And 128 and 64, I also know that's dividing by 2. So therefore, this is going to be dividing by 2 as well. But can you see how I used the smaller numbers to help me? I didn't start with the big ones. So I'm going to go 32 divided by 2. Well, that's going to be 16. Then 16 divided by 2, that's going to be 8. And then 8 divided by 2, that's going to be 4. So here I have a common ratio of a half. Perfect. All right, so that is the majority of what you need to be able to do. Common difference, common ratio. But also in the textbook, there are some tricky questions. So this is what I'm calling the challenge patterns. So let's go through some of these together and hopefully they prepare you for what you're going to see in the textbook. It says, find the next 3 terms for each of these patterns. Now, these patterns aren't going to strictly follow the common difference, common ratio. Sometimes there'll be a combination of both. Sometimes other crazy things will be going on. But just take it slow and we'll be fine. Okay, so what's the difference between 1 and 3? The difference between 1 and 3 is plus 2. What's the difference between 3 and 6? Well, that's plus 3. What's the difference between 6 and 10? That's plus 4. What's the difference between 10 and 15? Well, that's plus 5. And hopefully you can see what's happening here. I'm going 2, 3, 4, 5. So what I could write over here is I could say that the difference increases by 1 for each term. So therefore, I'm going to go plus 6 next, and 15 plus 6 is going to be 21. Then I'm going to plus 7, which is going to take me to 28. Then I'm going to plus 8, which is going to take me to 36. Perfect. Let's now move on to our next one. So here we have 1, 4, 9, 16. And instead of putting arrows here, I'm actually going to do something else. Just by looking at these numbers, you should be able to recognize something about them. And that is that this is a pattern. This is a pattern of squared numbers. So what do I mean by that? Well, 1 is 1 squared, 2 is 2 squared, 9 is 3 squared, 16 is 4 squared. So that means this one's going to be 5 squared, this is going to be 6 squared, and this will be 7 squared. 5 squared is 25, 6 squared is 36, 7 squared is 49. So this is a pattern of squared numbers. Okay, let's keep on going here and let's come to this one. So here we have 2, 8, 4, 7, 6, and 6. So what's exactly is happening here? So again, I want you to pause the video and see if you can figure this one out for yourself. So give it a go and see how you go. But I don't want you just mindlessly watching these videos. I want you to be giving these a go yourself. But this one is particularly tricky. So pause the video and give it a go. All right, so let's do this question. This question is rather quite tricky because what you need to be able to notice is that there is no pattern between each term like this. There is no pattern between each of them, but there is a pattern when we consider every second one. So for instance, 2 to 4 is +2 and 4 to 6 is +2. And then we can also say that 8 to 7 is -1 and 7 to 6 is -1. So therefore we could continue this pattern. We could say if we skip 1, this is going to be -1, which will make this 5. And then I can get my blue again, and I can say here to here will be +2. So it's going to be 6 + 2, which is 8. And then I'm going to +2 again. 8 + 2 is 10. Really quite a tricky one there, but you might see something like this in your textbook, so I wanted to prepare you for it. So what you would say here to describe it, I don't think you need to describe them in the textbook, but I still want to do it. What you would say is that the odd number, or the odd numbered terms, increase by 2, and the even number terms, even numbered terms, decrease by 1. So my odd numbered terms increase by 2 and the even numbered terms decrease by 1. Perfect. All right, my handwriting is atrocious. Okay, last one. For this one, I again want you to pause it and I want you to see if you can figure it out. And my only clue to you is that this is perhaps the most famous sequence there is. All right, so pause the video and give it a go. Okay, were you able to crack the code? All right, so for this one, what you had to notice is that if I take my two preceding terms, so 1 and 1, and I add them together, 1 + 1 is equal to 2, and that's this term. If I then go 1 and 2, 1 + 2 is equal to 3, and that's this term. Then I could go 2 and 3. 2 + 3 is equal to 5, and that's that term. Then I could go 3 + 5 is equal to 8, which is that term. So now what I'm going to go is I'm going to go 5 + 8. I'm going to go 5 + 8 is equal to 13, which means 13 has to be this term. Then I'm going to go 8 + 13. 8 + 13 is going to be 21, so that's going to be this term. Then I'm going, oh, sorry, did I forget a 13 there? Then I'm going to go 13 + 1. 13 + 21, rather, is going to be 34. Perfect. And now we have finished. So 1, 1, 2, 3, 5, 8, 13, 21, 34. What we call this is the, and I'll make sure I get the spelling right here, Fibonacci sequence. This is the Fibonacci sequence, when each term is the sum of the two preceding ones. So each term is the sum of the two preceding ones. That's the Fibonacci sequence. All right, perfect. So hopefully everything here has made somewhat sense in going through this. So this is all about patterns and sequences. Let's just go through our learning intentions again. Do you understand what number patterns or number sequences are? Same name for the same thing. a different name for the same thing, to be able to determine when there is a common difference, added or subtracted, to be able to describe a pattern where there is a common ratio, multiplied or divided, and to be able to find terms in a pattern where there is a common difference or ratio. So hopefully you can give all of these a big tick. You understand each of them. And yes, with that, I will let you go. Hopefully you found this video useful.